In 1983, this front panel was the face of global catastrophe. In the movie WarGames, it was the machine that dialed into a supercomputer and nearly tricked it into launching a nuclear first strike. It was the ultimate oops of Cold War-era Hollywood. Fast forward more than 40 years to today. This IMSAI on my bench is actually a microcontroller-powered replica, and the terminal is actually the Commodore 64 Ultimate, a modern FPGA reboot. In a world that's increasingly complex, there's something comforting about returning to a time when the logic was simple. So stick around. We're about to use these two machines to dial into the most dangerous computer in Hollywood history. The IMSAI 8080 was one of Hollywood's earliest star microcomputers. If you've seen the movie WarGames, you know this front panel. The original machine is a massive, power-hungry beast. This replica by the High Nibble is a faithful 1-to-1 scale recreation of the front panel, but inside it's running entirely on an ESP32 microcontroller. The microcontroller may handle the heavy lifting, but the way it interacts with the physical front panel, the way the address and data LEDs accurately reflect the state of the virtual 8080 CPU is just seamless. It's the perfect blend of vintage aesthetic and modern reliability. Since there was so much interest in my first Commodore 64 Ultimate review, I thought it was time to show you what kind of fun you can have by pairing it with other modern recreations of vintage hardware. And it doesn't get much more vintage or cinematic than this. This IMSAI replica was actually a donation to the channel from Polymat. If you're into the retro computing scene and you haven't followed his work, you're missing out. His retro restorations are legitimately legendary. He has this insane ability to take machines that look like they've been run over and buried for 40 years and bring them back to better than factory condition, practically to museum quality. Now's a good time to subscribe to my channel and maybe give Polymat a sub as well. Today, we're doing something that would have seemed like science fiction back in 1983. We're gonna get this IMSAI on my Wi-Fi network and then use the new Commodore 64 Ultimate to connect to it as its terminal so we can play some games. No serial cables, no level shifting or bit banging, just two legends talking across the decades. Unlike the original, the replica IMSAI sips power over a micro USB cable connected to the ESP32 board. When you flip the power switch up, the front panel comes to life. By default, the ESP32 acts as its own Wi-Fi access point. So from my Mac, I'll look for a network named IMSAI 8080 and join it using the password password. Once connected, we just head to imsai8080.local in the browser. This brings up the desktop GUI, a virtual window into the machine. This is actually really cool. It's a Windows-like desktop environment for controlling the virtual peripherals connected to the IMSAI. You've got your terminal, system info, and a config editor. It's a great way to verify that the hardware is happy before we move on to the next step. It's nice that the IMSAI replica defaults to creating a Wi-Fi network to connect to, but we'll actually want it to connect to the studio Wi-Fi network so the rest of my hardware can see it too. On the desktop, I'll open up the Sys app and then edit the boot configuration file. There are lines here for the SSID and password. Now we need to configure a virtual modem so the Commodore 64 Ultimate can dial in. Uncommenting this modem string tells the IMSAI's virtual modem to auto-answer and use the Telnet protocol. But since the C64 Ultimate communicates only at 38400 baud, we'll need to be sure the serial connection on this line matches. The save icon commits the changes, but editing this file alone doesn't actually tell the machine to stop creating a Wi-Fi access point. For that, we'll get really old school and flip some bits using the front panel switches. To force the machine to join an existing Wi-Fi network rather than create one, we need to enter the setup configuration mode. With the power switch off, press the ESP32 reset button on the back, then immediately toggle up the examine switch. The right to left chase pattern on the 4 status LEDs means that we're in. We'll mirror every lit LED by flipping the corresponding switch up and then add bit 3 to change the Wi-Fi mode. The deposit switch stores the new bit, and we can reset to reboot and join the existing Wi-Fi. With everything configured, we just need to tell the IMSAI that it has a real terminal connected to it, and it doesn't need to emulate one here on the web GUI anymore. With CPM running off the virtual A drive, this command redirects the text-based terminal output from the virtual modem. Once issued, the web terminal goes quiet here, and now the IMSAI is waiting for a caller. Now for the fun part. The Commodore 64 Ultimate has a built-in modem emulation layer that bridges the C64's serial logic to the internet. First, I'll jump into the Ultimate's configuration menu and make sure it's on the studio Wi-Fi network. Then I'll ensure that the modem emulation is set to DE00. This trick makes the C64 think that it has a SwiftLink modem attached, but instead of a phone line, it's going to use Telnet to call the IMSAI at its IP address over the Wi-Fi network. We're using CCGMS today, the gold standard for C64 terminals. After startup, F8 puts the terminal in text mode, and then I'll double check that the baud rate is 38400 and the modem type is set to SwiftLink. The IMSAI documentation shows that it should also answer to IMSAI 8080.local, but I can't seem to get that to work reliably on the C64, so I'll use its IP address from my router and indicate port 23 after the colon. The handshake, and there it is. I'll hit return to wake it up, and look at that. The CPM-A prompt live on a Commodore 64. Now that we're in, I want to try something. This is Kill the Bit, a 1975 front panel game by Dean McDaniel, originally written for the Altair 8800. Since the IMSAI is compatible, it runs here too. Back in the 70s and early 80s, video terminals were expensive, so most owners would have toggled this in with the switches on the front panel. But we're going to use DDT, the Dynamic Debugging Tool. It's a machine-level debugger for CPM that lets you enter and run code byte by byte. I'm entering 24 bytes of 8080 machine code. These instructions initialize a display register and rotate a bit through the upper 8 address LEDs. It's kind of cool to see the light cycle, and you're supposed to try to catch the cycling light by timing the flip of the switch below, but admittedly it's not much of a game. So let's see what other sort of games are on here. This is XY Basic, a basic interpreter for CPM from 1981. I'll try my name, I guess. No, that didn't work. Well, how about Joshua? All right, I'm in. Well, this looks familiar. Huh. Well, I'm not making that mistake again. Uh-huh. Let's be real. This IMSAI is software emulated at the CPU level, but the painstaking detail of this physical front panel creates a tactile experience that honors the original in a way that pure software just never could. You have the architecture of 1975, the home computer king of 1982, and the networking power of 2026 all working in perfect harmony. It's not just a setup, it's a bridge across computing history. About that basic program, the one that almost started World War III, it was actually running on the IMSAI, and I've linked to the basic code listing in the description, but run it at your own risk. If you're building your own high-nibble IMSAI replica or have questions about the C64 Ultimate, drop them in the comments. If you want to see more projects like this, hit subscribe. And if you want early access to the next video, my Patreon is the place. My patrons make it possible for me to keep bringing you Under the Hood. If you're looking for more content like this, check out my full review of the new Commodore 64 Ultimate from Commodore International. Thanks for joining me on this journey through computing history. I hope you'll find your way back here for the next Digital Voyage.